So, with pleasure, I welcome all of you to the last session, the final session of this 6-day STTP. So, all the participants be ready for the exam link. It will be posted in the chat box during the due course of this course. Okay. Uh, with pleasure, I'm inviting our resource person for the last day of this AICTE sponsored training program on IoT powered solutions for healthcare innovations. Our resource person is Mr. V. Hariharan. Sir is the CEO of the startup company Spacey Private Limited. Sir has mentored students and won various competitions like the Smart India Hackathon and the Mitsubishi Electric Cup and so on, and many more competitions. Previously, he was working as a project engineer in Trend Automation Private Limited. Sir, over to you, sir. Sir will be taking the topic fusion technology for healthcare. Welcome, sir.
Thank you, ma'am. Thank you for the invite.
You can share the screen.
Yes, ma'am. Let me share my screen. Kindly please confirm if my screen is visible, ma'am.
Yes, visible.
Okay. So, thank you for the hearty welcome to this evening on session on IoT. So, it's always a pleasure to be to do some connections and activities with KCG, and this is one among the day which I'm very grateful and happy to start the session with. So, before entering into the session, let me give you what is going to be the session on. The session is going to be on fusion technology and its application and implementation. How to implement fusion technology and what are the applications right now available and what are the futuristic scopes of application available in fusion technology in particular healthcare industry. This is what the session is going to be about. And a little introduction about myself. As said, I'm in 2017 passed out from the stream of electronics and instrumentation from KCG College of Technology. I started my career as a project engineer at Trend Instrumentation and Automation Private Limited. And in the year of 2018, we started a company called Spacey, which is on mentoring and giving solutions to all customized problems. Like if the student has an idea but they do not know where to approach and how to develop the product, we'll be mentoring them to develop a product or a project and make them to participate in various competitions, and we have also won various competitions across India. So this is what very little about us, and we are a kind of a notion to explore ourselves. So let's just jump into the topic. So this is what three categories which we are going to be handling today, which is on introduction of fusion technology, implementation, and application of fusion technology. These are the three categories which we are going to get into it. Before just going into the session, I just want one thing from your end, which is like a minimal point of interaction. I don't want this to be as a seminar or this to be as a lecture being lectured alone. I just want some interaction, any kind of questions related to the topic which has been discussed or the topic which is out of the discussion also. So you can just raise your hand anytime and you can just ask your question so that we can make it more interactive. Since most of them are faculties, you might know the situation of being interaction. So I hope there is a bit of little bit of interaction. Is very much happy and satisfied from my end. So let's start the session. Fusion. There is actually a famous statement which inspired me towards fusion technologies. Fusion will be the final way out for future. Being a very young kid, I always admired of, or I always messed up with mixing things, like mixing two different color solutions together form a different solution, and connecting these electric PCB boards directly to the power supply board. And I was just trying out and messing out things, removed my calculator completely and tried different options, tried different batteries connected to it and all those things. Being as a kid, I always tried these kind of things, which made me as an engineer right now. So these kind of fusion will always give birth to new thing. In fusion, there is nothing called, in general, it is 1 plus 1 is equal to 2, but in fusion, it is always 1 plus 1 equal to 3, where you always get a new product as a combination of your two products. So thus it was fusion. Fusion will be the final way out for all of our future. Right now, the development we are in right now in the globe, across the globe, is because of fusion technology. we'll get to know what are the developments we have been going through and how it has happened and all those things. So introduction, the timeline of innovation. If we see, not even taking from 1800s, we can just take apart from 1900 and 1090s, oh sorry, 1990s or 1970s part. From there, if we see, there is a very slow. There were huge inventions happening across that era, but what happened was like the era took longer time to elaborate, like longer time to evolve itself. Like if an very small invention was invented, then it took years or decades to cross across that invention. Like the innovation took decades to change itself or adapt itself. Let's say, for example, we had initially recording albums, then it transferred into CDs, compact discs. But the gap between these two, the recording albums and the CDs or compact discs, were huge. Like there were around 12 to 13 years of gap to change to that particular innovation. This is because there are two kind of approaches in R&D. In research and development, there are two kinds of approaches. One is breakthrough approach and one is technology fusion. Earlier, during the 1990s and all those periods, like in the late 19th century, sorry, in the late 20th century, there were lots of inventions happening, but where they are following through to the breakthrough approach. Like what is a breakthrough approach? Is it is a single step approach, step by step approach. You replace inventions instead of just combining inventions. They replace parts or they replace technologies to form a new evolution. So that is what breakthrough approach is. Like for example, semiconductors replaced the vacuum tubes. Earlier they were using vacuum tubes for the processing and storage purposes. It changed to semiconductor, but this was actually a replacement. Instead of vacuum tubes, we came for semiconductors, which was a replacement. Again, recording album, as I said earlier, recording albums were replaced by compact disc, which resulted in the usage of, right now we are into digital era where we use SD cards and internal ROMs for that. But initially, recording albums were replaced by CDs. So that replacement is what breakthrough approach results in. Like either the transistor radios were replaced by normal antenna radios, then it got converted by replacements. Right now, if you see, for example, TVs, earlier it were black and white, then it converted into color televisions, then into LCD, LED, plasma. Now it has gone to a very different extent. There is no replacement right now. So initially there were small screens or projection screen motion pictures, were used as entertainment purposes for viewing or viewing a picture, something like that. Later what happened, it was replaced by televisions. After television, it is not replaced, it is actually taking an advantage, or it is actually adding a feature to it. Like it was television, initially it was black and white television, then the feature of adding color came across, and it was color television. Then why don't we make our TV screens very minimal, or like a very small in size? It gave birth to LCD screens. Yes, ma'am. Am I audible, ma'am?
Yes, yes.
Okay. This is what the transition happened. Like there is no transition right now, there is no replacement right now, but there is a actual addition of features to all those technology which has been invented. Like color TVs, after color TVs, why not to add why not to reduce the size? They implemented LCDs, and why not we increase the viewing angle? So IPS LED panels came across, and now QLED panels and plasma TVs are giving a wide range of features across to it. So this is how a transition. But in breakthrough approach, there were no such kind of combinations. There were only replacements happening. So it was very much difficult for inventions to happen earlier. What is fusion? So fusion is actually mixing of different things. Like we usually do, right? Like we mix various combinations and we bring out results for that, and that would be something creative. So fusion is always a place where we have creativity to a higher extent, and the product will be and the product will be very much new, like it is a combination, it will be very new. So that is what fusion technology results in. So let me give you some very simple examples of how fusion technology has been evolved right now. Like in this world right now, we cannot use one technology, one industry. Like it is not no longer applicable right now, which means breakthrough technology, breakthrough approach. In breakthrough, we have one technology, and for that one technology, we'll be implementing in one industry. Right now, it is not happening. So, every industry can use different kinds of technology through R&D, research and development. So, what are the advantages of using fusion technology is like they are actually non-linear, they are complementary, and they're also cooperative. Non-linear in the sense it is not a step-by-step procedure. It can happen in no time. Like you can just bring in a very different technology in no time right now. Like for example, virtual reality and augmented reality is one kind of such technology which started at a very long period ago, but right now it has been in a very boom level. Like every industry is starting to adapt itself to virtual reality, augmented reality, and IoT combination. So this is what happening right now. What I'm trying to tell is, let me give you some very simple examples. Like there is a company named Sharp, which was actually in the 1980s. This fusion technology happened in 1980s. Sharp is a company which produced liquid crystal displays, that is LCDs. So what happened is like they combined electronics, they combined crystal technology and optical technology together, and they formed a very simple solution called liquid crystal display. So this is where calculators started to boom out. This is where calculators started to boom out, like combination of different technologies. For example, fiber optics. Fiber optics is actually the combination of electronics and optics. So these two together forms optoelectronics, which now resulted in fiber optic cable, which actually resulted in high-speed internet transmission. So the technology which we use right now is actually an expansion, or actually an evolution of that. The fusion technology happened long ago, like optoelectronics, which is the main reasons to start, which is the main reason to evolve to fiber optic cables right now, which we use for internet transmission, data transmission things. Mechatronics is actually a combination of mechanics and electronics, so which resulted in mechatronics, which is very much related to robotics and automation process in industries. Amazon has developed a whole complete AI based mechatronics warehouse where there is no human at all involved in operations. Like if there is a package has to be delivered, like if there is an order being done by an Amazon customer, then the warehouse will be completely taken care by the robotics and AI, which has been blended together there, which will take the order. Like let's say for an example, if I have ordered a shoe, then that robotic setup will take all the documentation process, and it will intimate the robotic setup in the warehouse. That setup will go and pick the shoe, pack it out, then send it out to the dispatch, where there will be a delivery man who will be taking to the delivery. So this kind of things are were possible only because of fusion technology. One more example regarding this is we would have known Nippon Technologies, which is like they were producing. There were many number of companies which started to use fiber optics. So Nippon Telephone is one of the pioneer in that. They started the fiber optic implementation across the globe. So that these are a very simple example. Two examples: Sharp and Nippon Telephones are the two best examples. These two are actually Japan-based companies which were pioneer in this. Like they started to evolve the fusion technology across. So how to implement it? Before implementing, I just want to have a bit of small interaction. Like is what fusion technology is understood, like what is a breakthrough approach and what is a fusion technology approach. Breakthrough approach is like a step-by-step procedure or kind of an algorithm or a standard where everything will be done as per the procedure. Like if this is done, then next this should be done. So it goes in that way. It will be replacing the technologies instead of combinations. So that is what your breakthrough approach goes with. Your fusion technology is like it is combining two or more different technologies to form an output or an result which is completely an added value service to that two combinations. Okay, so right now we always come across a word called 4.0, generation 4, and all those things. 4.0, industry 4.0 revolution, and all those things. I was really wondering what does this mean, this fourth generation mean? What does first generation mean? What does second generation mean? I really wondered when I started to hear 4.0. So I started a bit of research in that. Yes, ma'am. Is somebody wanted to talk? There is unmute between someone.
I think by mistake. One
Okay.
second, I'll mute all the participants.
Yeah. Okay.
Now you can unmute and speak.
Sure, ma'am. Thank you, ma'am.
Yeah.
So there are four generations happening right now in our 4.0. The first generation is actually like very long back, stones and woods and all those things. This is what I perceived. I intercepted like this. Like first generation is stones and woods where we used every material in a raw form. Second generation is like using copper, ions, and machineries and all those things. Like the revolution which was happening in late 20th century, and the boom of plastic is the third generation where we started to use every material synthesized with every material was synthesized artificially instead of just using it raw material, using it from natural resources. We started to produce it, or we started to regenerate it artificially. We synthesized it artificially. So that is what third generation is to my perception. And fourth generation is like custom designs, like generating new products by custom designs by manipulating in the sense combining various different things together and giving a very new product which is very much futuristic of the two products which has been combined. So manipulating and creating new designs is what fourth generation according to me. So first generation is stones and woods, which we where we were using raw form. Second is copper, iron, machinery revolutions. Third is your plastic artificial synthesizations happening, and fourth generation is right now where we create new create new customized designs, and we manipulate things to create a new product. So this is what four generations which I was actually thinking on. I was actually interested right now in the fourth generation where we are. So, is there any questions regarding this? Like to get an interaction, is there any questions from your end? Like what is regarding this breakthrough approach and fusion technology approach? If there is anything, please do raise your hand right now so that we can proceed. Or if there is no doubt, you can just comment it, type in the chat box. There is no questions or clarifications, then we can proceed with that. Okay, so I just assuming that the session is going good, since there is no questions or clarifications from your end. So let's go to the next one, implementation. Implementation is like we can think of any kind of concept. Like anybody can come with a very new idea. Anybody can come with an idea which can be the in the multiverse, or it can be in the parallel universe, or some kind of such ideas can come across with any person or any individual across the globe. But what is the real problem is implementation. There are n number of practical problems happening where if we need to implement such kind of ideas into realistic projects or realistic products. So in that aspect, what we want to do is, like, before implementing, we need to structuralize the idea which we have, and we need to implement that idea according to the need. Instead of just going for a mass market, we just need to focus or target narrow down or target to a particular group or particular audience. Then we just need to produce a product accordingly. Then we need to launch that. So this is how implementation works. But what in fusion technology is like, fusion technology is always non-linear. It is like you cannot expect something. You can have a desired output, but the process varies every time. So that is what fusion technology is. For one more example, uh, it is like starting from aerospace, steel, to software, whatever we use right now, every innovation is like quickening. It is not like it is not taking any given time to make ourselves adapt to it. It is quickening and it is like growing in a very faster pace. So to adding pressure to these kind of innovations, there is like cross industry boundaries. Like let's say initially there were one segment which was focusing only on mechanicals, one segment which was focusing only on electronics, one segment which was focusing only on aerospace, one segment which was focusing only on food industry, beverage industry, and all those things. What happened right now is there were intercombination between all those things. Like even food industry started to use electronics in it. Even food industry started to use mechanics in it. Even food industry started to use aerospace concepts in it. So this is what adaptation of technology came. This adaptation is because of fusion technology. So that is what I'm trying to do. Why I'm insisting on fusion technology is like right now all the innovations being happening are because of fusion, because of rise of fusion technology. So how it is being implemented? Since the topic we are into is regarding Internet of Things, I'll just give a detailed explanation of what is a combination of IoT plus different technology. So it is going to be IoT plus VR, IoT plus ML, IoT plus AR, and all those things. So this is what we are going to have a discussion today. So, before going into implementation of IoT and VR, IoT ML, and IoT AR, let's know what is IoT, what is AR, what is VR, and what is ML. Maybe the past 5 days of session you would have been given a detailed introduction on IoT, network security concepts, and implementation of IoT in domestic valuations and variations. So these you would have been came across to the past 5 days of session. What I'm trying to do right now is like give you a very small glimpses in a very short description so that you can understand all these topics. So that is what I'm going to try to do now. What is IoT? Let me give you a very simple example. We would have visited shopping malls and complexes wherever we are. We would have surely visited it once in our lifetime. So if we go into the malls or shopping complexes, there will be a counter incrementer. Like if you enter that arch, it will be giving you a beep sound.
Hariharan,
Yeah,
maybe
ma'am.
IoT part you can skip because we are in lack of time. The other
Sure.
topics, yeah.
Sure. Okay, so what is IoT is like in complexes there will be having counters which increases the number of attendees being attending or number of people came to the malls. That is completely hardware. There will be an IR transmitter and receiver which will be sending signals, and if there is any objection in between, the counter will be increases. This is what your hardware part is. The same principle, the same hardware based IR transmitter is being used in our cell phones, which is your known as proximity sensor. Whenever you get a call, if you keep your phone near to your ears or face, the screen blacks out or locks itself. So this concept is very similar to the same IR transmitters or receivers which is being used in shopping complexes. What is happening right in phones is the hardware does not take action on its own. It relies on a software. That is, whenever or only whenever there is a call, the phone screen blacks out if the proximity sensor is detected. If there is no call, if there is no function depending on this proximity sensor, then there will be no screen lockouts happening. So this is because the software and hardware is combined together to perform a specific task. To do a specific task, hardware and software is combined together. So this concept is known as embedded system. Implementing IoT or internet, giving internet to such kind of embedded system is known as Internet of Things. To be very simple, adding internet to an embedded system is known as Internet of Things. For its operations, for its control, for its acquaintance and all those things, if we use internet, through to embedded system, that is known as Internet of Things. Let me give you one. uh, Internet of Things is like, to state it very simple, internet of everything, combine giving internet to everything. Like for our mobile phones, there were no internet, but once internet has been given to it, there was a very huge development in the mobile industry. Same wise, if we give the people started to think, what if we give internet to mobile, this much of evolution has happened. What if we give internet to every device across us? Like if I tell to my fan, hey dude, come on, switch off yourself, and then if my fan switch off itself, then it is working on Internet of Things concept. Right now, industries has come across with products that implements IoT in their IoT as a real-time product. Like there is a refrigerator in a brand which messages you or texts you that there is no eggs being available in the refrigerator. So while coming by eggs or something like that. So these things are having IoT implemented in them. So this is IoT. What is AR and VR is like augmented reality and virtual reality. Augmented reality is like bringing some other world into a real world. For example, Pokemon Go is a very good example for AR, where you will be where earlier the students were running across the roads to find a Pokemon across them. So this is what AR is, bringing different world to our real world is known as AR. Virtual reality is like going into some other different world. Avatar film is a very good example for that, where the main character, lead character of the film will be put into a box and he will be in some other world, the Avatar world. So that is an example for virtual reality. ML is like machine learning, which learn itself, which tries to adapt itself to whatever it is learning. Initially, it does not know what is a car. Like similarly, during a small age or a young age, we do not know what is a car, whatever stuff we around us, we do not know. People will start teach us, this is car, this is water bottle, this is laptop, and this is keyboard, and all those things. So in such a way, machine starts learning according to itself by its error compensation techniques, or build its own model depending on the learning it had, and all those things is known as machine learning. Now what is happening is like combining all those things. Let me give you a very simple example of implementing IoT and AR in a real world. So connecting the dots is like connecting all this technology. This is one good example where AR and IoT has been implemented in a shopping complex of Audi. Audi. So it is like having an AR segment where you will be seeing actual replacements, like something. There is no actual name or name board is there, but using the AR technology they have implemented. So this is AR building, where you can actually build an in real time. It is not present, but in our augmented setup or in our mobile phone, it is viewable with all those specific details. In real time, this car is not present, but they have made it an augmented setup. So augmented, this is actually an augmented race which has been happening as a competition across the globe. So augmented reality placed number plates. So this is what the implementation, like to know what is happening around, like how. Let me give you some very basic examples which we have been doing. We have been doing concepts on digital twins. We have been developing projects on related to IoT and fusion technology projects. which I can give you as an example. First one is in healthcare industry, we did a project for dental students where practicing of dentistry or aspirants of dental colleges is very difficult. They cannot have a real time practice at all. So what we did is like we developed a prototype. We initiated the process actually. We developed a prototype on which is similar to human. We took all details about human face and human teeth and all those things, dental aspects. We developed it in augmented reality and we gave it to the students to practice it. So these kind of things are being implemented across the globe. And there is also one more project which we did for doing surgeries to cut the human skin. There are actually precision need to be done, like 0.3 of incision will be done to cut the skin and 0.5 to cut the tissue and all those things. So these kind of precision was controlled using equipments, huge equipments in industry, which has been monitored or which has been controlled by a human. Human will set the frequency and the robotic arm will cut the person lying in the operating theater. So this is what happening in Russia. They have this kind of prototype developed. What they wanted to do is like they wanted to implement IoT into it. So this is actually a robotic setup which cuts the or do the operation. They want to implement the IoT concept where the doctor can control it from his home. Like instead of just visiting the actual place and doing operations, the doctor or the doctor can be in his home or in his own place or remote location, and he can operate the robotic arm to cut or to make to perform the operation. So that is what the other projects which we did. So these are the two things which we were working on regarding to IoT and fusion technology in healthcare. Let's go into the example. This is one good example for using fusion technology in our healthcare. We would have come across X-rays, scans, and scan reports and all those things. What if those scan reports and X-rays can speak themselves? Like what if they can give data instead of just getting data, collecting data in a report? What if they can visualize it, visualize the data to the doctor or to the person who sees it? So this is one example where the X-ray will be displayed to the doctor with the details like time of taken and the structure of actual structure and the fractured structure and all those things comparison. All these things can be displayed to the doctor or the person who is having the X-ray with his hand. So this is what one concept. Second is like during surgeries, there are very much complications can happen. Like for example, if an cut need to be made for 3 inch, that 3 inch need to be done. What if we have an IoT, AR, and ML segment combined device which can assist the doctor to make the cuts, which can provide inferences on to the doctors like what is happening, how it should be done, and all those things. And it can be also controlled by remote location. So all these things combined together. Right now, AR plus ML is combined. IoT plus AR plus ML can also be combined to bring these kind of results. Like let's imagine one concept. Like I'm a doctor in an operating theater, OR room. There, I have a little bit of minute confusion. What to do next? Like if there is a complication happened beyond the surgery, during the surgery there is a complication happened right now. So I want to do such resolve it at that moment. So during that time, my segment, like my assistant of AI assistant with augmented reality can provide me inferences like what can be done, how it can be done. This can also be used for training purposes. Instead of just going directly into the operating theater, students can use these kind of technologies to learn and adapt themselves, and they can be trained with much more details. Instead of just having a book written details, they can perform it live with using augmented reality technology and AI technology. So these are the two topics which has been used in industries. Before continuing, I just want to have a 2 minute of interaction with all of you over there. So just let me know if there is any doubts or questions so that we can proceed.
Hello, sir.
Yes, sir.
What's your thoughts about full dive VR?
Sorry,
What's your thoughts about the full dive VR and how can we implement practically?
full day
Ex-
VR.
Full dive VR, which means experiencing the virtual world in real life using sensors and additional
Yeah,
actuators like that.
yeah. I can get that. So, can you please be elaborate about the question?
Uh,
He's
uh,
asking how to implement different methods and what software and tools can be used for implementing VR.
Okay, so there are various softwares being available for development of AR and VR. One such is Unity, which you have come across while playing games. Unity is one of the software which has been developed for developing development of AR and VR. Unreal Engine is one famous tool or software which
So
has
are these
been
open source?
they are open source to a limited extent, ma'am.
Okay.
We can use it. The softwares are available. We can use all those softwares and we can program and develop it on
Okay. Can
ourselves.
you
But
repeat the tool names for the participant? I think
I
it
can
is
just type it in the
Tanush.
chat box.
Yeah, maybe that.
Unity.
yes, I know. I worked in those softwares and all.
Okay.
I'm asking about the practical implementation of those projects. Like, what sort of software, what sort of how can I say, sensors, or what sort of devices can we will be used to.
Yes. I can just give you an example for that. What is the advantage of these kind of technologies is like you need not to have a limited kind of sensors and all those things. You can connect n number of sensors, n number of concepts can be implemented using this. There is no limitation at all in this. Like when you combine technologies, there is no limitation at all. Let me give you an example where we did a real-time project again using digital twin concept, which is on VR, virtual reality segment. What it is like in industries, we have pumps. Those pumps need to have capacitors to run. So that capacitor, if there is any amalgamation or happened, anomaly happened, this capacitor, if there is an anomaly happening in this capacitor, then the power supplied will be higher, so the pump gets interrupted, or there will be variation in the pump's force given and all those things. So to overcome that, capacitors charge, the capacitor's value was being monitored, and it was proposed to change using a robotic arm. But the real problem here is these pumps are situated in a hazardous area. A human, if a human goes, that is not actually a good place for a human to go and visit and do those things. To perform that, what we did is like we implemented VR technology. We developed the actual pumps, the real industry pumps, in the sense we built a structure which looks alike that the particular area. Let's say it looks like the particular pump house area. We developed it in the virtual reality. We connected with a robotic XY robotic arm which moves around and picks the capacitor from the pump and replaces it. So this is what we have done using digital twin concept. So there is no limitation of implementing these things. You can use various sensors like temperature sensors, which are very much available in commercial, DS11, DSB, DS180B, and all those things. So there is no limitation at all. This is what I am trying to tell. Am I clear, like Mr. Dhanush?
It's okay, sir. Okay.
uh, there are various kinds of projects can be implemented. Like for example, to harvest in field, let's say this as a very good example, where to harvest in field, if you need some human to actually place it. Instead of what that we can do is we can develop an augmented reality or a virtual reality setup, and there will be a robotic arm which actually harvests. What happens right now is like I can create the experience for the user that he is actually harvesting it. Instead of just robotic arm is harvesting, he can monitor it from here and he can have the feel that he is actually harvesting it. So such kind of experience can also be made using virtual reality and augmented reality setups. So this is one happening right now, and a few other examples to tell. Digital twin. Audi car has been implementing digital twin concept where they actually bring in the engines instead of just going for opening and let's say I'm a mechanical engineer and I want to service an engine. Let's keep it in such a way. What happened is like, but I'm not sure how this engine performs or what is the start of this engine, all those things. I need to remove it and I need to check it out, check out the complete details to service it. What Audi has done is like they develop a system where there will be a QR code scanner, or there is an actual app from them, or a web browser where you can log in and you can just scan the car. If you scan the car, it will be giving you current all details of that particular car, like what is the coolant temperature in an augmented reality view. Instead of just having it in an data, like written data, it has in an augmented reality view where your car parts will be cleanly shown, and it will be it can be removed out in the augmented reality setup itself and check what is the problem in that, and based on that inferences you can implement that in real time. So this is what the happenings around the globe regarding augmented reality and virtual reality. Am I clear, sir? Is there anything else should I continue with? So, Mr. Dhanush?
Yes, sir. You can continue.
Okay. Yeah, okay. Thank you. Thank you. So, if there is any kind of questions like this, if someone has a question, can just unmute and ask so that we can have an interaction. Any kind of questions regarding to augmented reality, virtual reality, digital twin concepts, IoT, and all those things. I'm just expecting anyone to question. Okay, so let me proceed with the further things. Let me give you further more applications in IoT and VR segment. So as I said, fusion is like, this is what we have been looking earlier, like making the people in the people who are studying medical science can try themselves or practice themselves, because there is a very less practice they have. So they are all observing students. They only observe and implement in real time, which is once they become a doctor. But these kind of practices can be given to them using fusion technology. This is one happening. During the recent COVID pandemic time, there was also one of the project which has been developed by IIT Chennai students, where the patient monitoring was very much tedious during the pandemic session. Like if there are hundreds of patients in a particular ward or in a particular room, we need to check temperature. Then we need to check their SpO2, their breathing should be monitored, and all those things should be monitored regularly for every patient. This has become tedious for doctors to visit them and do that. Doctors or frontline workers like nurses and all those people, where it was tedious for them to go and take such readings from the patients. They need to cover themselves with full PPEs to visit them and take the readings. What these IIT Chennai students did is they developed a device which is an handheld device which will be connected to the wrist or fingers of the patient. This device will be continuously monitoring the temperature, the SpO2 and heart rate of the patient, and it will be giving it to it is actually an IoT device, and it will be giving it to the dashboard which they developed for the doctors. Like for every patient, with their name, with their ID number, bed number, and all those details will be given to the dashboard. No actual doctor or nurse should be available there. They can just go to the dashboard and look into it, and they can start taking actions regarding the details given in the dashboard. So this is one kind of IoT which has been implemented and implemented over there, and this has been evolved to such an extent that it will also give recommendations. What kind of treatments can be given based on the report of the patient. So these kind of things were also happening across during this pandemic. This IoT plus VR or these kind of fusion technology has grown rapidly. So that is what I was trying to tell. There was also one more incident where doctors started to use AI's assistant to do perform an operation or perform a specific task on that patient. Like even industries, they started to use this concept where if I need to go and thread, or if I need to go and tighten and bolt an industry, I might over tighten or I might lose tighten. So these are the two scenarios which can happen while using this kind of IoT and this kind of fusion technology, that is particularly AR VR concepts. I can go there and have a glass held towards me, like a spectacles or a goggles, that will insist me to thread it 3 times or to tighten it like 4 times or something like that. So it will be giving me detailed description so that I can act accordingly. Same has been implemented in healthcare industries, particularly in operating rooms, which has been in research purpose, which is not directly implemented till now, because in medical industry it takes a bit time to test and do it implemented. So in that way, people started to use, like in research purposes, they started to use this kind of AI assistants, where it will be giving them assistance of what is the disease been happening to that patient based on his medical reports, what kind of treatment can be given, and if there is anomaly happening during the treatment, what kind of alternative solutions can be given. So these are step-by-step procedures which has been happening in industries, happening in medical industry too. So this is what happening. This is what a very real-time example which I came across in my life of implementing fusion technology. So this is what I was telling about using AR in dentistry. People can practice like they are actually performing an operation to that particular person. Like you can see in the screen over there, where the person is actually having a view or an experience. The doctor is actually having the experience that he is really operating to a person. So such kind of experiences will be done so that they can practice and make themselves better, because practice makes a man better, right? Like in that concept, so they can have n number of practices without hurting any kind of people. So this is what I was telling about the AI being used in industries. So in a dental industry, what happens is like one, it will detect all kinds of problems. AI will be detecting all kinds of problems based on vision technology or supervision, computer vision technologies and all those things, and it will be giving such kind of details to the doctor so that they can perform actions accordingly. So these are the very simple examples and applications of IoT fusion technology which is being used. So before going into the next one, I just want to have again 2 minutes of conversation with you, so that we can take it proceed. Any questions from your end again, like anything related to the topic like this? What is IoT? What is AR? What is VR? And what is ML? How it has been implemented? What are the companies which has been using these topics? Audi is one of the very topmost brand which everybody would have known. Mitsubishi is also implementing remote PLCs, where we can take control action for PLCs instead of just being there. Like PLCs are used in industries as controllers. The evolution of controllers, like very long concept, where initially it was mechanical, then pneumatic, then it came to electrical, then electronics. Right now, in advanced controllers like PLC and DCS. So these are the evolution of controllers which we have been we came across. In that, right now we are in PLC and DCS era, where PLCs cannot be connected to internet. That is what the actual standard which has been followed in industries. But what Mitsubishi came across is like they developed a remote PLC, that PLC can be monitored or controlled remotely. Like they'll be giving 5 different devices which can be logged in for that PLC. Using that 5 different operational level hierarchy, one person can control it, one person can only view it, and all those things. For those 5 devices will be given option. So in that way, what happens is like Mitsubishi has developed to get controlled, like to control the PLC, which is never available till now, which is also a combination of IoT plus automation field. Then I was explaining about implementation of digital twin concepts, which we went into the Mitsubishi Electric Cup competition, where we proposed this concept, and we also gained much good reviews from them. And we also developed an AR dashboard for bikes and cars, vehicles to be in simple, where you can actually view the details of the particular vehicle in AR mode, like what is the current fuel consumption level, what is the speed, current speed of that vehicle, what is the battery level of that vehicle, engine oil level of that vehicle, fuel indication. All those things will be viewed on an AR dashboard, where instead of just viewing uh, uh, directly in the dashboard which we have in our vehicles. So this was also we were implementing. We also implemented one more topic called smart helmet, where which is a combination of again IoT plus AR. These two were implemented to give a surreal experience to the drivers or the riders of bikes, so that they can do much. They can add features to their car, which is a smart helmet which we developed with the team. These are the very basic concepts. So before going into the next one, I just want some kind of interaction, any kind of questions from your end to take it. So I'm just expecting a question from your side, any kind of questions.
You can proceed.
Sure, ma'am. Sure, ma'am.
Yeah.
Sure, ma'am. Mr. Danu, it was intimated that you were asking about Neuralink. Can you just rephrase the question again so that I can give you a bit of explanation on that?
Okay, so that's a vast topic. Neuralink is nothing but it's like a helmet or headgear in which
Yeah.
the person who's wearing can experience the VR world by means of transmit. I can't explain in a single sentence.
Yeah, you can just tell what you have understood so that I can take it further. That is not an
First, the data is collected by in real life by
Mm,
like sensing stuffs like touching, walking, stuff like
mm,
that.
mm,
And
mm,
as the data is stored, and
mm,
in the VR world, when you're doing the same function like operation, you're like walking or stuff like that.
mm,
That data is again sent to the Neuralink headgear,
mm,
and that gear will send a small amount of microwave signal or electric pulse to the specific
mm,
part of the brain,
mm.
in which that part of the brain is activated, or how can I say? Mm,
Yes, I can understand your question. I just want you to explain it so that other can understand your question. So that is what
yeah, yeah,
what I understood from your question is like you are asking about kind of an interface, brain
yes,
computer interface kind of thing,
yes,
right?
yes, yes, yes.
So which was earlier called as BCI, brain computer interface is what people were doing. Like
But this is for VR applications. Like if you, for example, if you build a game,
hmm.
in the game world, you can experience the user can experience what the character is experiencing, like
Yes,
that stuff.
exactly. So that is what happening. Neuralink is what doing these kind of activities. What is your question regarding this? Like, you wanted to know how it has been implemented, or what is the technology being used in all these things, or
Uh, and I have no doubts regarding the theoretical part or
okay.
um, instrumentation parts and all. But I want know what kind of sensors I should I use, what kind of technology should I use for data collection. What sort of medium can I use for data collection and transmitting that data to the gear? Practically, I'm talking about practically.
Yeah. I can understand that. So But this is not actually a very small concept to be explained in a very short time
Yes, yes,
period.
yes.
But what I can give you is like, I can give you a hint. What Neuralink was using is like they were using 6 probes, which was actually inserting around 192 electrodes, I guess. For every minute, there will be an insertion of 190 electrodes using the robotic system which they have in Neuralink. Okay, so that is what these probes collect data. So for this, there are various sensory devices available. There are various sensory sensors like to collect alpha and beta waves. There are EEG sensors which is available. There are brainwave sensors which is available, and all those things need to be collected. And these are used for collecting brain signals. Based on these brain signals is what experience has been created. Okay, so that these kind of like I'm not sure about the exact name of the sensor. Brain sensor in general is what they use
Yes,
for
EEG sensor.
collecting beta and alpha waves of human brain. So that you can use for that the collection of data. Second is like to control segment to get it connected with the other devices or to make an communication establishment. You can use various kinds of other controllers, which is like to be in very specific. Atmega is a very simple or a very higher end controller which can be used. Okay, Atmega. So you can have a note on that if you need it. So Atmega is the controller which can be used for processing all these data. Okay, so that is one. And probes, I can you can just get connected with me later on so that I can give you some references on the probes which we have earlier done reading some projects on that. So we can just connect it in that way.
Sure.
Yeah. Okay. Thank you. So any other questions?
Excuse me, sir.
Yes, sir. Yes, sir. Please go ahead.
Sir, I have the same question. Actually, previously you insisting that at Maha, it means
Yes.
Arduino Maha you are saying or some other things actually?
No, sir. Arduino is actually a product of Atmega. So the IC which has been used in Arduino is Atmega 328P. This is what the IC they have been using. There are various advanced Atmegas being available. So Atmega is like the overall controller. Arduino is development board. It is not actually a controller. It is a development board which has been used for easy implementation of works. If it is of a chip, we need to do different kind of programming. That is completely different. If we use our development boards, it will be easy for programming. It is used
So
for
what will
domestic
be the
purposes.
total cost on an average? What will be the total cost for implementing this technology?
The IoT, this fusion technology, or you're asking about the Neuralink alone, na?
It's a neural link, I'm asking.
It depends, ma'am. We cannot predict a cost with very minimal information. It need to be have a detailed description to say such cost at a very big
There is
amount.
another question from Sudha V in the chat
Yeah.
box. What are the different challenges in fusion technology?
Challenges in fusion technology. Yeah, there are again as it has very much uh, exploration field. There are also limited challenges. Is like you need to have knowledge on different aspects. If you are using a, let's say I'm using going for embedded C alone, I can have a very good knowledge in embedded C alone and develop it to my product or project or all those things. But if you are using fusion technology, you need to have knowledge on different stuffs. Like I need to have knowledge on ML, I need to have knowledge on IoT to combine both. So that is one very big challenge is where people stop themselves from learning in one technology instead of just going for the other. So that is one technology implementing human wise. Regarding the implementation part, the results can be very different. As it cannot be as expected because your desired output cannot be achieved 100% using fusion technology. If you are going for a breakthrough approach or a single step-by-step instruction approach, you surely will be reaching your desired output. So this is one of the challenge in using the fusion technology. So these are the two challenges which we can address.
There is one more query from the participant.
Yes,
Are you able to view the chat box?
yes, ma'am. Can you explain software and hardware requirements, basic fusion and neural technology? Okay, great. So fusion technology again is completely different. Neural is completely different. So let me give you what are the basic components to build a very basic product. Let's say this robotic setup which we used we developed for changing the capacitor of a pump. There we use an XY robotics which was completely running on Arduino itself. We developed it using Arduino itself, Arduino as stepper motor and some basic mechanical setups to move that conveyor belts and all those things to move that robotics. Second, the second part is your PLC, which is to control the pumps and to collect data from the industry. So we are using an PLC for that. Then third part is your virtual reality segment, where we need to have Oculus Go, which is one of the famous Oculus. I'm just typing in the chat box. Oculus Go is one of the famous VR, which is very minimal in rates, which can be easily purchased, and we implemented that. So that has been developed using Unity software. The environment in the virtual reality, we developed it using Unity software. So we can develop or we can combine technologies using very minimal, which we have just without our knowledge itself, we have been using fusion technology, which is cloud computing concept, where you will be sending real-time data to your cloud. From there, embedded C to cloud computing technology is also a fusion technology. So fusion, it is not very mandate to have higher end complex electronics or complex mechanical equipments with us. So this is regarding the fusion. For neural technology, regarding the hardware part, we need to have probes and sensors to understand the brainwaves, to capture the brainwaves. That is what I was telling about brainwave. Brain sensor is one very minimal or very affordable sensor which can capture alpha and gamma beta waves of human brain. So that can be used. We can capture EEG signals using sensors, which again results in concepts of collecting data. So these can be done using hardware part. Collection part, processing part, and transmission part can be done with all kinds of basic controllers and sensors which we use. Example, Node MCU is one of the very good example for implementing IoT. Node MCU, I'll just type it in the chat box again. So in Node MCU, what it does is like it has inbuilt Wi-Fi functions, Wi-Fi enabled functions, so that you can connect any kind of devices with your internet and make perform task or perform operations using that. So Node MCU is very much enough to perform such kind of higher operations too. But what happens is like the limitations of having number of inputs and outputs changes. Like if, for example, I cannot connect many analog inputs or analog devices to my Node MCU. If in that case I need to go for a higher end, like I need to go for Atmega other models, so that I can connect more analog devices. So this is what the very basic thing about fusion technology. And also it is not mandated to use higher technology at all. You can implement fusion technology using our very basic kit which we have, like Arduino, few sensors like temperature sensor, humidity sensor, pH sensor, and all those things. With those itself, we can implement these kind of fusion technology. For example, I have been telling about IIT Chennai project, right? They are detecting the temperature, pulse rate, and SpO2 heart rate, and SpO2 of patients. They were using what are the sensors they use is like they used Node MCU for controlling and transmitting to the cloud. They were using heart rate sensor, which is around 200 rupees alone. So they used that. Then for temperature measurement, they used two kinds of sensors. One is DHT11, the other is DS118B sensor. So these kinds of two temperature sensors they use. The total cost of this is like will be around maximum of 1,000 rupees alone, including the power supply, batteries, and all those things, which would cost around 1,500 alone. But they developed a product with all those basic products alone. So this is what I'm trying to tell. Start with very basic components alone. It is not that mandate you need to go for higher end, but we need to understand the requirement. This regarding this Neuralink and neural technology, we can assist you. If we can understand, if you can give us your requirement, this is what our requirement, and we need to develop such kind of project or product. We can assist you in that extent. Because without knowing in detail things, we we are afraid to let out things which might mislead to some other extent. So any other questions similar to this? I'm happy that getting interactions with you guys. So this is one very simple interpretation of how devices can be actuated to healthcare. Like your heartbeat, your heart rate details, as I said in that earlier project, we can connect all those things. We can connect a device, we can connect an equipment to human body for parametering, condition parametry monitoring. We can collect it and give it to the dashboard. So we can view it, we can have remote access of it. So those kind of things can be done with this fusion technology. This is one simple example. This is like a kind of an interpretation which I wanted to do. Various companies started to do. Bose is also starting to implement IoT. Siemens started to implement IoT in their industry segments. IoT and virtual reality together, they started to implement. Car companies like hybrid electric vehicles right now is actually an implementation of fusion technology, where you'll be combining two different technologies like traditional combustion engine, and there will also be electrical engine which you can switch accordingly. So that hybrid cars are also evolution of fusion technology, where again smart cars, in smart cars they are using IoT and ML technology together to bring out a very good user experience. Let's say for example, the tire pressure of a particular car is reducing at 2 psi for every 1 kilometer. Let's keep it in that way. For every 1 kilometer, there is a reduction in 2 psi. Let's keep it in such a way for an example. Okay. So what happens is like your controller or your system can understand that there is a problem happening because there is a continuous decrease in 1 psi for every 2 psi for 1 kilometer. So what happens is like it will start to think what is the real problem. It will do the analytics and give it to the dealer itself directly, or it will give it to the user itself directly, so that the user can understand what is the problem going to happen. Instead of just problem happening, instead of just understanding a problem after happening, the system provides the information before itself, before it happening itself. So that's kind of things are being implemented right now. So in smart cars, which is very much blooming technology right now. EVs are also very much booming right now, and particularly in India. So these are the concepts which utilizes uh, fusion technology with them. So any other questions similar to that? You can be very it is not that mandate to be very specific on any other topic alone. You can just ask or open any technology so that we can have an introduction to that. To add one more point on Neuralink, we cannot be directly testing Neuralink projects to human at all. So there are various limitations. And regarding the healthcare industry itself, there are various limitations since it deals with humans and human lives. So what happens is like there are various testing procedures need to be done. There are various approvals need to be done in every country, depending on the country. So that's why it took around 8 months. Actually, it is a year, 1 year testing procedure need to be done to let out and vaccine for trials. So what happened is like it took 1 year, 8 months due to some various laws being implemented. It came in 8 months itself. So there are various limitations in healthcare industry which need also be considered while developing projects or product in healthcare industries. So any other question, final questions? So this is actually the market of these technologies. There have been in the 2020 market of these technologies which we are discussing all on. 6.1 billion for VR market, 761.4 billion for IoT market, and 62.4 billion for ML market. So IoT has been for the past 5 to 6 years, which has right now a huge potential market. Various companies are starting to implement automation IoT segments towards their industries, and ML, VR, AR are segments which are being implemented right now. There are VR stations and AR stations being used across petrol bunks and abroad, where people can fuel their car and play during the time period which their car is being fueled or something like that. So those two are ML and VR are huge potential markets which has been booming right now, particularly in India, with various automation segments being invested in India. So those two concepts with fusion technology will be having a very great or bright future across. Digital twin is one important concept which all industries are trying to adapt themselves. So if you can come across to the digital twin concept, kindly just involve yourself in those kind of projects. So that will be very much helpful for your career and future. Any final questions? If you have any questions, you can just question me on any segments similar to the interactions which we are having till now.
Anyone have any other queries? So Hariharan, I think we are done with the session, right?
Okay, ma'am. Okay.
Okay.
So
So
thank you for this. Thank you for the wonderful opportunity to get interacted with various dignitary persons across India. So it's a great pleasure being here. Thank you for the session.
okay. So thanks to V. Hariharan for this informative session of making the participants think beyond IoT and how the fusion technology of IoT and along with AR and VR can bring about a change in various industries, including the healthcare industry, and also for making the point across that any project including IoT, AR and VR, if it is applied to medical industry, it has to go through elaborate testing process. Okay. Thanks once again from the management of KCG and from the coordinators team. All the organizing members would like to thank V. Hariharan for spending his time and effort towards this STTP. Thank you.
Thank you, ma'am. Thank you for the
Yeah.
opportunity.
So let me conclude this session. So this is the fourth and the last phase of this STTP, AICTE sponsored STTP on AI and IoT powered healthcare innovations. We have trained more than 410 participants. With pride, I can tell that we had got very good feedback for all these sessions. So we had conducted this event for 28 days and trained approximately 410 participants. I take this opportunity to thank the chairman of AICTE and the director of faculty development cell AICTE for giving us this opportunity to have this elaborate training. And in fact, we thank AICTE for taking such very good steps to train the faculty across India on various upcoming technologies. And that too specifically during this pandemic time. I take this opportunity to thank the management of KCG College of Technology and our principal, Dr. P. Devasundari, who has given her support and guidance towards making this event a success. I thank the participants for attending this event and for even for continuously attending for the 6 days. So I could see an average attendance of more than 60 on all these sessions. Thanks to the participants in making this event lively, and without you, these events are not at all interesting. Thanks to all the resource persons who had supported us on all the 28 days. In fact, almost all of them have put their best effort and they have supported us to a large extent. Thanks to all the resource persons. And last but not the least, I thank all the organizing team members who have supported me along this entire process. Specifically, I would like to thank Ms. Ramya from Department of Electronics and Communication Technology for actively doing majority of the works. And I would also like to thank the other team members, Ms. Shanmugapriya, Mr. Thomas Leonard, Mr. Nateshan and Dr. V. Balaji, who had supported me in making this event happen. And now let us go to the last session, that's the exam session. Also, we'll be sharing the link now. We will be making the link active for 1.5 hours, since this is the time when the college might close and you might be on travel. So we will activate the link for more than 1 hour. Please attend the test, and the attempt is only allowed once. So once you attempt, the link will get closed. Okay, thanks once again to all the participants. And once we consolidate everything, the marks and the attendance, and we'll send you across the certificate within 1 week. Thank you again. So any problems from the participant side, I'll be online for another 15 minutes. We will be sharing the test link. Ms. Ramya, can you share the test link?